Back again, 10 more minutes of measles in DRC. This time we want to talk about preemptive mobilization during epidemics. And let's start once again with a bit of context. So this is the slide that I began my first presentation with. Now, the astute observer may have noticed that I suspiciously ended my epidemic curve at the beginning of 2022. If I were to add the more recent months of data, you would see this, a troubling curve that looks not dissimilar to our massive epidemic in 2019. Now, I want you to hearken back a little bit to that epidemic in 2019 because it was historic in its scale. During that period of just over a year, every single province of the country experienced outbreaks. And in those outbreaks, we observed over 380,000 cases and over 7,000 deaths, both of which are expected to be gross underestimates. Now, in the hopes, given this troubling trend in recent months, of avoiding an epidemic on the scale of what we saw just 3 years ago, MSF has asked Epicent to help identify health zones for preemptive mobilization, be that vaccination, pre-placement, etc. Now, how do we do that? Well, just as I had 2 goals in my previous presentation, this time I have 3 questions. My first question is that of risk. Where do I think outbreaks are most likely to occur? My second is that of timing. Among those outbreaks, which do I think will happen the soonest? And finally, if at all possible, I would like to have the question of scale. Which of those outbreaks will be the most severe? Now, we already have a pretty good idea of what types of indicators we can use for these first 2 questions. For instance, the question of risk can be not answered, but we can have an idea of it by looking at vaccine coverage, and I use an independent and population-based estimate, as well as the amount of time that has lapsed since the last outbreak. Similarly, for the question of timing, we know that proximity to current outbreaks is going to be a relatively good indicator. But that brings us to our question of scale, and unfortunately, we actually don't know really what indicators might be good. We might hypothesize, for example, that those health zones which have had major outbreaks in the past are the ones most likely to have major outbreaks in the future, or perhaps it's going to be population density, or perhaps it's going to be something else. And that's going to be my focus in this second talk today. What indicators can we use to try to estimate the future scale of a health zone level outbreak? And let's begin with that hypothesis that the historical severity is going to be a good predictor of severity in the future. So here you can see a distribution of the size in terms of number of suspected cases across all health zones, and this is the first outbreak I saw in each of those health zones. So for example, we might take Kailo, which in 2016 had an outbreak of 2,890 suspected cases. Now be careful here, because I'm talking about the first outbreak I saw, not the first outbreak in a specific year. So if we look at another health zone, for example, Songa, we will see that the first outbreak I saw was not in 2016, but in 2015, with 1,102 cases. Now my question, looking back at Kailo, is it's in the tail, and that's really where we want to look. We want to look at those health zones which have really large-scale outbreaks. And my question is, if I look at the second outbreak I observe in the same health zone, is the outbreak going to have a similar size? Is it going to be in the tail again with about 2,900 cases? Now, unfortunately, what we saw, I suppose not unfortunately for Kailo, but unfortunate for our analysis, that was not at all the case. And in reality, the next outbreak observed in 2021 had only 513 cases. Now, let's look at that at a bigger scale, right? Because maybe this is just an exception. And if we do that, we can look at our first outbreak size on our horizontal axis compared directly to our second outbreak size, looking for a correlation. So here, each dot represents a specific health zone, and once again, we have our example of Kailo. Now, if my hypothesis is true, that the historic scale is a good indicator of the future scale, we would expect those dots to roughly follow this line. And in fact, if it were true, we would expect data that looks kind of like this, where here I've added in some imaginary blue data, which represents well-correlated examples. Now here you can see in gray our original data, and what we see is that actually there's no real evidence of correlation in our real data. So let's get rid of our pretend example data And what we see in general is that not only is there no evidence of correlation in terms of outbreak size, but also in terms of outbreak deaths or in outbreak duration. And taking that together, what we find is that the scale of past outbreaks is simply not a good predictor of the scale in the future. Well, okay, so maybe we can find another indicator, something that's a little bit more stable. Well, we looked at a large number of indicators, such as population size or density, case fatality, mortality rate, and several others. So here, for example, we can see a graph that would look for correlation between population size of a health zone and the number of deaths that they have on median across all of the outbreaks observed. And once again, we see that there's no real correlation there. And indeed, there was no evidence that any of these indicators were a good predictor of outbreak size or number of deaths. And as a result, this goal was dropped. So where does that leave us? Well, it leaves us with our first two questions, that of risk and that of timing. So for risk, I create a simple scoring system that starts with vaccine coverage, again, from an independent and population-based survey. And I'm going to say, if you have a vaccine coverage equal to or less than 70%, you get 1 point. If it's less than 50, you get an additional point. I also want to consider the history of recent outbreaks, and specifically large ones, which I define as at least 500 cases. If you haven't had any in the last 3 years, then I give you 2 more points. For timing, again, we want to look at physical proximity. And so I give 1 point if you have at least one of your neighboring health zones with a current suspected, note suspected, not confirmed, outbreak, and 1 additional point if there are at least 2. So to take an example, we can look at Bhutao, which had 2 neighboring outbreaks at the end of April, with a vaccine coverage estimated at 52%, and no outbreaks observed in any of my data, which started in 2015. So I'm then going to give it 2 points for those 2 outbreaks, 1 point for a vaccine coverage of less than 70, but not less than 50, and 2 more points because it hasn't had any recent large outbreaks, giving us a total of 5. Now, if I do this across the entire country, we find a plot that looks somewhat like this. Now, here in gray, we can see all the zones that had a suspected outbreak. Again, this is data dating back just to the end of April. Sorry about that. And then in colors from yellow to red, we see our estimated prevention score, higher meaning more likely of having an imminent outbreak. Now, I want you to look at 2 main things here. The first is that high-scoring zones are often clustered around outbreaks, and that tells me 2 things. First, that's a sanity check. It tells me my system works like I want it to, because I want it not just to look at underlying risk, but also look at imminent risk because it's close to an area that has an ongoing outbreak. But it also tells me that these scores are going to evolve as the epidemic moves throughout the country, making it a dynamic system. The second thing I want you to notice is that ties are common, and in fact they're allowed by design, meaning that multiple health zones, and in fact many of them, can have the same score. Now the reason that I've done that is because I want this system to be just one consideration in broader discussions of strategy, because other factors, such as logistics and whatnot, will also go into the conversation. Taken together, this system is designed to be simple and dynamic, providing a basis for broader discussions of prevention strategy throughout the epidemic. In conclusion, in our second talk, we've developed a simple system to orient preemptive mobilization during the ongoing epidemic of measles in DRC. The system uses a combination of vaccine coverage, time since last epidemic, and proximity to suspected outbreaks to identify zones at high risk of imminent outbreak. Point systems like this one can provide a useful initial ranking to help focus attention and facilitate rapid decision-making as the epidemic evolves. And with that, I'm going to stop here, once again thanking all of our colleagues at Epicentre and MSF who were instrumental in the creation of this system. So thank you, everyone.